solve for x in a triangle, round your answer to the nearest tenth. This is going to be your theta. So theta equals 41. X is going to be your adjacent. Across is going to be your opposite. And then your diagonal is going to be your hypotenuse. So we know theta equals 41. And because we're trying to find adjacent, we want to do adjacent over hypotenuse. So that's going to be cosine. So cosine of 41 equals x over 14. And then you're going to cross multiply. Cross multiply cosine of 41 times 14 and then x. So then that's going to be 14 times cosine 41 equals x. It says round to your nearest tenth. The adjacent side is equivalent to 10.56, which is approximately 10.6. Number 2, a ladder leans against the side of a house. The angle of elevation is 74 degrees. How high is the top of the ladder from the house? Round your answer to the nearest tenth. We are looking for the height. The height is this right here. That's what we're looking for. So if we look at this triangle on its own, the theta is going to be 74. Excuse me. The hypotenuse is going to be 16. And we're looking for the height, which is going to be the opposite side. So to find that with what we're given, I'm going to say that we want to use the sine function. So we're going to say sine, not 64, 74. Sine of 74 is going to be equal to x over 16. We're calling the opposite angle x. And then we're going to cross multiply. 16 times sine 74 equals x. And then when you put it into the calculator, it just looks like that. So we know x is approximately 15.38. And if we round that correctly, x is 15.4. Angle 1% from the horizontal. The plane's current altitude is 7.4 kilometers. See the figure below. Find the plane's new altitude h after 0.25 hours if it travels at a constant speed of 500 kilometers per hour along the direction of its flight. Carry your intermediate computations to at least 4 decimal places. Round your answer to the nearest tenth of a kilometer. Okay, so we need to know that this height and this height are the same. So these little hatchings mean that they're the same height. They're parallel and they're the same height. That means that this is parallel to this. And we're going to go from there. So let's call this H2. So we also need to know that we're going to use distance equals rate times time. And in this case, your rate is 500. Your time is 0.25. So that means our distance is going to be 500 times 0.25, which is a quarter of 500, which is 125. 125 is this line right here, the hypotenuse. So this is 125, which is also your hypotenuse. So let's go ahead and determine what H2 now means. So that's part 1. And now we're going to determine H2. So we're going to take the sine of 1 degree equal to H2 over the hypotenuse of 125. Because as it goes, the sine, this is the opposite, and this is the hypotenuse. So H2 is also known as the opposite angle. So right here, we're going to what we call cross multiply. So what I mean by cross multiply, we're going to take the sine 1 times 25 and then multiply it by whatever H2 is multiplied by. In this case, it's going to be 1. So we're going to have 125 times sine 1 equals H2. And then we put that in the calculator. We're going to get H2 is equal to, in the instructions, it says to use 4 decimal places. So when I put that in the calculator, I'm going to get 2.1816. But the question is asking us to determine what this H is equal to. So what's this H equal to? And to figure that out, we're now going to say that we have 7.4 equals H2 plus H. And 2.1816 equals H2. So 7.4 equals 2.1816 plus H. We're trying to determine what H is equal to. Again, this is H. So we subtract 7.4. We're going to take away 2.1816 from that. And we're left with H is going to equal 5.2184. Your angle is X. And then we have the adjacent side as 15. And the opposite side is 12. So it's going to be tangent X equals 12 over 15. So we're going to do the inverse function of 12 over 15. Now in tutoring, what we've been doing is using Desmos. Just to change it up, we're going to use Desmos for a couple of these problems, and then we'll go back to the 84. So when you go to the tool button here, we want to make sure we're in degrees, the way it says in our problem here, right? It says degree. So let's highlight that. So we're going to say function tangent inverse 12 over 15. That's going to give us an angle X of 38. And it says to the nearest tenth, 38.7 degrees. Number 17 says a ladder leans against the side of a house. The top of the ladder is 14. So This is 14. And then it says, find the angle of elevation of the ladder around your answer to the nearest tenth of degree. Let's see what this looks like. So that means that the hypotenuse is 17 and my angle is x. So if we take this triangle and we move it away from this picture, we're going to say we have this right triangle where I have 14, 17, and x, right? Now, based on the sides that we're given, we have the opposite side and we have the hypotenuse. So we're going to say sine of x equals 14 over 17. We're going to perform inverse sine of 14 over 17 to find the value of x, which is the angle. Again, we want to make sure that everything's in degrees. I didn't do that, so that's what happened. So we assume that x is approximately 55.4. All right, let's go ahead and look at number 6. Number 6 says, solve the right triangle. Round your answers to the nearest tenth. Okay. So let's put this in order. We have capital A, small b. So that means if we label this is A, big B, big C, and this is small c. So B, big C equals 90. Small b is 51. These are angles and these are sides. And then small c is 22. Okay, so the way we're labeling this is going to be adjacent. B is opposite. And 22 is the hypotenuse. So we're going to do sine of 51. degrees, and that's going to be equal to small b over c, which is 22, the hypotenuse. So here's how this works. We're going to do cross multiply. We assume that the sine 51 is under 1. So when we cross multiply, it's going to be sine of 51 times 22 and then 1 times b. So 22 times sine 51 is going to be equal to b. 22 sine 51. B is equal to 17.1 because it says to use the nearest tenth. So that's 17.1. We also need to find A. So we can take the cosine. So this is something else. Let's take the cosine of 51 again. And that would be equal to small a over 22. And then we're going to cross multiply. We assume cosine has a 1 underneath it, so it's going to be 22 times cosine 51 equals small a. So small a equals 13.8. And then we need to find big A, which is the angle. Now, we know that every triangle is equal to 180 degrees. So to find big A, or angle A, we're going to say 180 minus 51 minus 90. So that's going to be angle A is equal to 39 degrees. So we basically had to figure out the solutions for all the blanks of this triangle. So we found A, B for the sides, and small angle A. Okay, David sees hot air balloons in the sky that are shown. He determines that the lower hot air balloon is 425 meters away and at the angle of 31 from the vertical. The higher hot air balloon is 560 meters away at an angle 43 degrees from the vertical. How much higher is the balloon on the right than the balloon on the left? We're basically trying to determine this part right here, but we need to look at two different triangles. So let's look at the triangle on the right. So on the right side, we have a triangle. It's a right triangle, but it's upside down, where our angle is going to be 43. And I'm going to call the side that they share adjacent side 2. So this is the adjacent side, but it's A2. So let's organize this in a different way. And we're given 560. That's going to be the hypotenuse. So we can say cosine of 43 is equal to A2, or adjacent side 2, over 560. And then we can cross multiply to get the value of A2. So this is going to be 560 cosine 43 equals A. Now, this says do not round intermediate computations, and I already started to do some math over here on the left. I'm going to leave this the way that it is because this is what we called an exact value. And as you can see, this, even though it doesn't show all the values of the answer, it's 409.55 and just goes on and on. So we're going to use this as part of our solution. So that's the length of the adjacent side 2. Now, the triangle on the left is the smaller triangle. So left side. And when we look at that other triangle and when we're drawing it, our side, the adjacent that we're looking to find the value of, is going to be shorter. So this is also a right triangle, but it has an angle of 31, and the hypotenuse is 425. And we're going to call this side adjacent 1. So A1 equals adjacent 1. I want to take the cosine of 31 is equal to A1 divided by the hypotenuse of 425. And then I'm going to cross multiply to solve for A1. So I have 425 cosine of 31 equals A1. The question is asking us, how much higher is the balloon on the right than the balloon on the left? So when we put this all together, you're subtracting the value. So you're trying to find, again, this green part. And let's just call this A3. So altogether, A3 is equivalent to the larger side, which is A2, minus the smaller side, which is A1. And then we're going to use exact numbers. So 560 cosine 43 minus 425 cosine 31 equals A3. And that's the difference of 45.26. And we want our answer to the tens place. So A3 equals 45.3. And that's the whole problem.